Our lesson on 5.2 part 1 is going to cover just the basics of factoring. We're going to come back to 5.2 part 2 in the next unit, but for now we're just going to start with basic factoring. So, give me a minute while I untangle my cords here. Alright. You may have done a little bit of factoring in your Algebra 1 class, hopefully, and you'll remember that factoring is the opposite of FOILing or distributing. So let's begin by reviewing FOILing. So when you have a binomial times a binomial like this, you FOIL, which is first times first, and then you do the outers, the inners, and the last. It's really just distribution. So x times 2x gives us 2x squared, and then the x times the negative 4 gives us negative 4x. The 3 times the 2x gives us a plus 6x, and then the 3 times the negative 4 gives us a minus 12. So we're going to combine our like terms in the middle here, and our final answer would be 2x squared plus 2x minus 12. Alright, so moving on. We're going to do that, but we're going to go backwards. Now the first few problems I'm going to show you are really easy, and they're going to be just what we call diamond problems, where we're looking for two numbers that multiply and add to a certain set of values. Later on we're going to see some problems that are a little bit harder. So you might have to do a little bit of guessing and checking, not on these first few though. So let's put our two parenthesis sets down and remember what this means. This number right here is the first times the first. This last part are the last two numbers multiplied together, and then the middle part of the trinomial is the outer plus the inner. So let's start with the easy part. What times what will give us x squared? Well, we know that's going to be an x and an x. That's the only way to get an x squared. Now for this first problem, I'm looking for two numbers that multiply to give you a negative 28, but then they add up to give you a negative 12. So I think about some options for negative 28, and it could be negative 14 and 2, or negative 2 and 14. Could be, let's see, 7 and negative 4, 4 and negative 7. There are some other options, 28 and 1. But if I think about what are the options I just said, how about a negative 14 and a positive 2? I think that would work. And I'm going to write it down, and I always double check what I did before I leave the problem. When you do the outer plus the inner, it should add up to a negative 12x. So outer would be a 2x, and inner is a negative 14x, and if I add those two together, I sure enough get a negative 12x, so I know I did that problem right. So my answer is x minus 14 times x plus 2. So we're going to do the same technique here for number 3. I'm looking for two numbers that multiply to give us x squared, so that's x and x. And now I'm looking for two numbers that multiply to 4, but they add up to 5. So it could be 2 and 2, but that doesn't add up to 5. So how about a plus 4 and a plus 1? Okay, my next example, I'm looking for two numbers that multiply to 14 but add up to 9. So could be 14 and 1, could be 7 and 2. I'm thinking 7 and 2 works. And that gives me 2x plus 7x, which is 9x. And then my last example in this row, it's got to multiply to a negative 80. And it's going to add up to a positive 2. So since it's got to multiply to a negative 80, it's going to be positive and negative. So there's a lot of options. I'm thinking 8 and 10 might be it. So if we did a positive 10 and a negative 8, that would be a negative 80 multiplied. But when you add them together, that would give you a positive 2. So we have the right answer. So hopefully those easy, what we call diamond factoring problems, come to you pretty quickly. Now we're going to talk about more Algebra 2 based problems. A key difference you might notice here is that your first number is no longer x squared. You've got something else there, some other coefficient besides a 1. Unfortunately, that makes our job a lot more difficult. So this time you will have to do some guessing and checking, and the better you get at these, the quicker they'll go, but it might take you a minute. So we're still going to start with the 3x squared. What times what will give us 3x squared? Well, I know that's going to be a 3x and an x. That's the only way to get a 3x squared. So now I'm going to think about multiplying to give us a positive 10. Don't worry about the negative 17 quite yet. Well, if I want to multiply to get a positive 10, my options are 10 and 1, 5 and 2, but it could also be negative 10 and negative 1, or negative 5 and negative 2, and then to make things even more complicated, the placement of the 5 and the 2 or the 10 and the 1 is going to be important because this 3 is going to amplify whatever is on the outside here when I multiply it. So I'm just going to throw something down and hopefully it works. We'll check. Now I notice in the middle it's got to add up to a negative number, so that tells me putting two positives down will not be helpful. So I'm going to use two negatives to get to a 10. So let's just try, and I don't know if this is right, let's try a negative 5 and a negative 2. Now when I check the outer plus the inner, if it gives me a negative 17, then I did this right. So let's see, that gives me a negative 6x, and that gives me a negative 5x. Well, does that add up to a negative 17? No, it does not. So that is not my correct answer. So I'm going to try again. Maybe let's stick with the 5 and the 2, but let's switch where they are. Let's put the negative 2 right here and the negative 5 right here. So now, when I check outer plus inner, I end up with a negative 15x and a negative 2x, and when I add those together, I do get a negative 17x. So that is my correct answer, 3x minus 2 times x minus 5. The better you get at these, the more easily you'll see the answers before you write them down. Don't be afraid to try something and then either cross it off or erase it and move on. Okay, number 7. Multiplies to a 2x squared. Well, that's going to be a 2x and an x. Now, I notice everything's positive, so that means everybody's going to have a plus sign. And good news, there's only one way to get a 3 times a 1. Now you have to be careful where you put the 3 and where you put the 1, because this 2 out in front is going to amplify whatever gets put over here on the back end when I do outer plus inner. So if I'm trying to multiply the outer plus inner and add them together and get a 7, what if I put a 1 here and a 3 here? Let's try that. So on the outer, I've got a 6x, and then on the inner here, I've got a 1x, and if I add those together, I do get a 7x. So that was the correct placement for my numbers. Okay, number 8. Kind of bad news here. We've got, I'm going to move it down here, we've got an 8x in front, and there are a few different ways to get an 8x. You can do 8x and 1x, you can do 4x and 2x. I'm thinking the 8 is just too big to make this problem work. So I'm going to choose 4x and 2x and assume that's right for now. Okay, let's look at the last number. I got to multiply two things to get a 9. Well, it could be 9 and 1, or it could be 3 and 3. Again, I'm thinking 9 and 1 is just going to be too big to make this problem work. So let's try a plus 3 and a plus 3 and see what happens. So when I check outer plus inner, let's see, I get a 12x right here, and then I get a 6x right there, and when I add those together, I get an 18x in the middle, which is what I wanted, so we chose well. That is the correct answer. Okay, number 9, 18x squared at the beginning. So 18x squared, 18, there's a couple different ways to get that answer. It could be 18 and 1, could be 6 and 3, could be 9 and 2. I'm just going to try 6 and 3. I don't really know if it's right, but we're just going to try it. Now, to multiply to give you a negative 14, could be negative 7 and positive 2, could be negative 14, positive 1. You could flip those all around. And then to make matters worse, the placement of the 7 and the 2 is going to be critical. So I'm going to just go ahead and try, and again, I don't know. I'm going to try a positive 2 here and a negative 7 here, and let's see what happens. So when I do outer plus inner, let's see, I get a 12x on the outside and a negative 21x on the inside. And when I add those together, I get a negative 9x in the middle, and notice I wanted a positive 9x in the middle. This is good news. We're actually really close to done. Since I got the right answer, but the wrong sign, all I have to do is switch my signs. Everybody's in the right place. So the answer is really 6x plus 7 and 3x minus 2. And that's the correct answer for that factoring problem. All right. Sometimes you're going to have a problem that has a common monomial factor. So, and when I look at this question, number 10, I think about what is in common between an 8t squared and a 4t. What can they both be divided by? Because you always want to factor out common terms before you start actual factoring. And I noticed they both have a 4 that I can take out, and they both have a t that I could take out. Now if I factor out that 4t, it's kind of like dividing by a 4t. You're going to be left with a 2t, and then right here if you take 4t and divide by another 4t, you're still left with a minus 1. So that problem becomes 4t times the quantity 2t minus 1. Okay, number 11, there's a common factor of 3 that everybody can be divided by. And the reason we want to take out the common factor first is because it makes this a much easier factoring problem next. Oops, that's an 8. So, when I look, that was supposed to be a 2. Hello. Mrs. Abruzzo can't divide today. So when I look at this first problem, or second problem, number 11, what's left in the parentheses can now be easily factored using one of those diamond problems. So what multiplies to a negative 8 but adds up to a positive 2? I'm thinking a plus 4 and a minus 2. So now this answer right here is your full factorization. If you never factored out that common 3 at any point in the problem, you're technically not factored all the way, and I could not count you correct. This next problem, I have a common factor of 5 I can take out, and that gives me x squared minus 4 in the middle. Now we haven't discussed this pattern yet, but there are two numbers that multiply to negative 4 but add up to a 0. And the way this pattern works is it's going to be x plus 2 and then an x minus 2. This is called the difference of squares pattern, and we're about to talk about that right now. So if you notice, you have two perfect squares and they're being subtracted. The pattern it factors into is a plus b and a minus b. So basically all I need you to do is square root each of the numbers and then put a 1 a plus and 1 a minus, and you're done. So here for number 10, if I were to square root an x squared and a 9, I would have x plus 3 and an x minus 3. And that's how you factor that. That's my absolute favorite factoring problem because they're so easy. Now, perfect square of a trinomial, or perfect square of a binomial, gives you a perfect square trinomial problem. It's not as important that you recognize this pattern because it's, not always easy to see. But if you notice that the last and the first numbers are perfect squares, so this is a 1 and this is a 6 if I square rooted it, the middle number would be double the product of the first and third numbers. So 1 times 6 is 6, and then if you double it, you get a 12. So if you notice that this guy is a perfect square trinomial, you can factor it into, x plus 6 squared. Now if you didn't recognize the pattern and you just tried to factor that by hand and you did x plus 6 times x plus 6, that's fine. It's the same exact answer. Now you're going to notice the next pattern is very similar. The only difference is it's now a difference of a binomial. So again, the first and last are perfect squares, and if I square rooted them, I get 1 and 4. And then if I double that, that's how we got the 8 in the middle. So using our pattern, it's x minus 4 quantity squared, but you could have just factored that using your normal factoring techniques. Alright, number 13. This is the difference of two squares. So this is the pattern where we just simply square rooted both of them, and then we made 1 a plus and 1 a minus. So this gives us 2x in front and a 5 in back, and then 1's a plus and then 1's a minus. Now in number 14, you might notice that this is a perfect square and this is a perfect square. And if you do notice that, you might notice that this is the square of a binomial pattern. So the square root of that would be 3y. The square root of this would be a plus 16. And then quantity squared, if I think about refoiling that, the reason they end up with a plus 24 in the middle is, hello, I really screwed that up. That was a 4. Goodness. Alright, plus 4. 3y times 4 is 12y. But because you're foiling, you're going to end up with 2 of those, and that's why it doubles in the middle to a 24. Again, if you don't like that pattern, if you don't like to memorize that, you can just factor it like normal. So number 15, again, perfect square on either end. This time though, it's a difference in the middle because it's a negative 14. So we have 7r minus 1 quantity squared. Again, you don't have to use the pattern, but it is nice if you can recognize it. Now on the back of this worksheet, I'm actually not going to do any of these for you because it is going to be kind of a homework assignment during class. So using these factoring techniques, you're going to practice this. This does not come easily to everybody. You need to practice it. Do not copy off each other. Do not copy off a friend. Do not have someone do it for you, because your proficiency in factoring is going to dictate how easy the rest of this class is going to be for you. So if you have any questions, come see me before school or after school.